Hi, today we're talking about CCM8, Unit 2, Lesson 3. This is about converting repeating decimals to fractions using algebra. So what is a repeating decimal? A repeating decimal is a decimal that, after a certain point, consists of a group of one or more digits repeated. For example, 0.717171. Also, it has a bar notation, which you'll see sometimes. And the bar, it goes over the digits that repeat. So in this case, both the 7 and the 1 repeat, so the bar is over both. Vic number 1, this might not make sense the first time you do it. This concept is very interesting, but just stick with it. It will make sense after a while. So here's our first example. We have 0.44444, the 4 repeats over and over again. Rewrite as a fraction using algebra. So when we use algebra, we use equations and variables, so all of that is going to be what we use today. So let's say that this decimal is equal to x. So let's set x equal to this repeating decimal. If we multiplied x by 10, we'd get 4.44444 repeating. So we have another equation here. 10x equals 4.44444 repeating. Our ultimate goal here is to get rid of the repeating decimal, the repeating part. So let's use algebra and subtract our equations. So what I did is I took this equation here with the 10x and I put it on top. And then I took my original equation, the x equals, and I put it underneath. I lined up the equal signs, the x's, and the decimals here because I'm going to subtract. So I drew a big line and a subtraction sign. I'm going to subtract straight down, just like you would a 2-digit number. Just subtract straight down. 10x take away x. Well, when x is by itself, there's an imaginary 1 in front of it. It's like having one of those. So 10x take away 1x is 9x. 4.44444 repeating, take away the 0.4444 repeating, gives us 4 by itself because this cancels out with this. So I'm just left with 9x equals 4. Now this is easy. All I need to do is use inverse operations to get x by itself, which means divide both sides by 9. And I figure out that, hey, 4/9 is my answer. So this decimal, repeating decimal, is equal to 4/9. Done. Not so bad. Let's try another one. Here's another example. 1.22222 repeating. So let's use the same process. I'm going to set x equal to my number, and then because I just have one digit that repeats, I'm going to multiply by 10. So if x equals 1.22222 repeating, then 10x equals 12.22222 repeating. I just multiplied this number by 10 to get this number. Now let's use algebra and set up our equations and subtract them vertically. 10x minus x is 9x. 12.22222 repeating, take away 1.222 repeating, is just 11 because my repeating decimals cancel out. 12 take away 1 is 11. And now just use inverse operations to get x by itself. So our fraction is 11/9 or 1 2/9. Now we're going to get to a more challenging problem. What if you have 0.323232 repeating? So now I've got 2 digits that repeat. I'm still going to use the same process. Set x equal to your repeating number, but now instead of multiplying by 10, I'm going to multiply by 100. Because we want to get rid of the 2 digits that repeat, we've got to multiply by 100. So there's 2 repeating digits, multiply by 100 instead of 10. So here's my 100x equals 32.323232. I set them up to subtract, just like I have in the other problems, and look. They cancel out. The repeating part cancels out. That's what we want. So 100x take away x is 99x's. 32 take away nothing is just 32. And then I use inverse operations to get x by itself, and I've got my answer, 32 over 99. Again, taking it a step further, it's getting a little bit more challenging. I've got 0.813, and look, we've got bar notation, and the bar is only over the 1 and the 3. That means that the 8 does not repeat. The 8's just there, and then the 1, 3 repeats. 1, 3, 1, 3, 1, 3. So I've still got 2 digits that repeat, so I'm going to multiply by 100 in this case. So I've got my regular number that we started with. I'm setting up a new equation, and I'm going to subtract. Watch what happens when we subtract. Remember, when you're subtracting, you're setting up your variables, one underneath the other, line up your equal signs, and line up your decimals. Because when we add and subtract decimals, we line up the decimals. When we line them up, you'll notice something. The 1, 3, 1, 3, 1, 3, 1 cancels out, but that 8 is still there. That's okay. Don't freak out. We're going to subtract. 81.3 take away 0.8 is 80.5. That's okay. We're still in good standing. So I've got 99x's equals 80.5. Use inverse operations to get x by itself. So when you do that, your fraction is 80.5 over 99. Well, I've got a decimal inside my fraction. That's not really okay. To get rid of the decimal, we have to multiply the numerator and the denominator by 10. So 80.5 times 10 is 805. 99 times 10 is 990. I can simplify this fraction because they are both divisible by 5. When we do that, we get 161 over 198. I would have never guessed that that fraction was equivalent to this decimal, but it is. And we got there all through algebra. Okay, I've got one more problem for you, and then we're all set. 4.957. This is in bar notation, and the bar is over the 9, the 5, and the 7. I've got 3 digits that repeat. I'm going to use the same process, but now I'm going to multiply by 1,000 because I've got the 3 digits that repeat. So here's my original number. Here's my number after I multiply it by 1,000. I set it up to subtract. Again, when we subtract decimals, we line up the decimal. Our repeating part cancels. And now I have 1,000x minus x, which is 999x. 4,957 take away 4 is 4,953. So I've got, when I solve for x, I've got 4,953 over 999. I can change that number into a mixed fraction, and then I can reduce my mixed fraction, and I've got 4 over 319, 4 and 319 over 333. Again, take these problems slow, set it up the way we did here. This is probably the easiest and simplest we can get it for you. Okay, hope you learned something.